Hi, everyone, and thank you for joining our presentation today as part of Horizon 360 meetings. Our presentation was scheduled based on the interest of most of the attendees when we mentioned UPV. Many of the Horizon 360 members and the technology and innovation members, they were interested to know more about the software, its usage, and many of our members, member companies, they volunteered to share their experiences, and we thank them for that. So today we are going to have start with, of course, the safety moment. And then we're going to hear from Sigi from CAXperts, the developers of UPV software. We're starting with an overview about the company, the software, UPV software, especially for the ones who are the first-time users or viewer of the software. And then it will be followed by example of use cases and the use of this technology by Dow and Bechtel. And then we are going to end it up in the last session by hearing about the latest updates of the software, what's the roadmap, and what's next. For the last session, we'll have Q&A session, and hopefully we'll be able to answer all of your questions. Anything which is not answered, we'll try to follow it up by emails or any calls after that. So please, if you have any question during the sessions, try to post it on the chat and we'll try to follow it up. So starting, instead of the safety moment, it will be more like of an awareness about the World Water Day. You know, last Wednesday was the World Water Day, which is an annual United Nations Observations Day held on March 22nd of every year to highlight the importance of fresh water. So basically, it's about accelerating the chances to solve the water and sanitation crisis. So it's like a reminder to each one of us to play our role, play our part in doing what we can do to make this crisis less impacted on our environment. So simply, we choose from this list that you can see as an example. We select some of these that we think that they are very important to us, and we contribute to the nature. So as an example, the three most popular actions in Europe and Northern America are saving water, which is by having shorter showers or moderating the usage when brushing teeth or washing dishes, stop polluting from pollution from food waste, oils, medicines, and medicals, eating local. When you buy local seasonal food and local products made with less water. Other actions can be like cleaning the rivers, lakes, fixing leaking water and damaged pipes, and many more. So it's like a call for each one of us to be the hummingbird to start the action to react to the crisis. Okay. So as I said, we'll start with our first speaker, Sigi. Sigi is the technical director at CAXperts, and before he has a long experience in the IT CAD systems management with Lindy and other companies before joining CAXperts. So I will stop sharing, Sigi, from my side for you to share and present your slides.
So my name is Siegfried, or short as Sigi Schott. I'm technical director of CAXperts, and today I'm going to tell you only very few slides about CAXperts, a little bit about UPV, and at the end of the session, I give you an overview or an outlook on upcoming features. Okay, CAXperts, we are a German-based company. The headquarters is near Munich in Germany. last year we celebrated our 20th anniversary. We are independent and we have around 150 customers in 30 countries around the world. So on the right side, you see we are often now voted as one of the best employers in the IT market or overall in Bavaria. So our customer base is nearly equally spread around the world. So 1/3 in Europe, 1/3 in Asia, and 1/3 in Americas. And to give you just a feeling what our customers are, so that's some of our customers. So some of them, like BASF, are using our software globally. Some use it only in some facilities. Some are just starting up to roll it out globally. So that's it. And now I'm going to show you some slides about our main product, which is the UniversalPlantViewer. So here it is. So it's so just to give you a feeling how it looks like. And let me start up the slides. Okay, Universal or UPV short, what is it? So it's a project we started 2013. It's now 10 years ago. And the initial idea was to see if we can use a gaming engine for viewing plants. And it turned out it's not as easy as we thought it would be. In the meanwhile, we've jumped over all hurdles and it's doing quite well. So therefore, the name was UniversalPlantViewer, which in the beginning we thought is a good name. I don't like it so much anymore because while it's still universal, in the meanwhile, it's not only for plants. So it's also used for shipbuilding, for offshore platforms. We have customers using it for BIM. And it's far more than a viewer nowadays. So there are a lot of enhancements over the last 10 years. So maybe you see it in the use cases. So what functions does it have? I can tell you all functions. When we started UPV after about 3 or 4 years of development, it used to take about 30 minutes to run through all the functions. We can view 3D models, we can view PNIDs, we can do markups, we have a very powerful search, we can highlight objects, we can do clipping of the model through several aspects, we can comment models, we can colorize them by attributes, we have measurements. So in the end, we have all functions you expect from a viewer and many more. So nowadays, I more like to talk about what use cases you can cover with UPV. And there might be all the standard viewer use case where you want to have a look on your 3D model, on PNIDs, documents, attributes, and things like that. But you can also use it as a communication hub. So maybe you might want to give data during a bidding phase to potential contractors. So you can do that very easily with UPV. You can just place it on a website, open the website up for the companies, and once the bidding phase is over, you can just stop access. You can use it as a digital twin. So you can really link to all other systems and documents. You can bring in additional data to the model. So you can really bring it to life as a digital twin. You can maybe use it as a platform for managing your advanced work packages. So there are developments ongoing at the moment to make that possible. It's already used as to do PNID commissioning systems inside UPV. So for startup of new plants. So it's used for turnaround planning. So, you know, turnarounds are very expensive, and with UPV, you can, in a very early phase, start planning your turnaround so that when the shutdown comes, everything you can track inside UPV, you have all the information in the model. You can do simulations like crane simulations, see if things are fitting together, and much more. So it comes in different flavors. So there is a local app. So it's just either a portable exe, so you only have to double click the exe and it starts up. There is also an installation version in case you want to deploy it via some deployment systems. So also that is possible. We have a mobile app for Android and iOS, so you can use your mobile phone, or better, you use a tablet on site. So it's also possible, if allowed, to download the whole plant to a mobile device and use it offline without any internet connection. We can run it in a browser, so with zero footprint. And if you use our web services with the browser-based viewing, you can open up even huge models within 2 or 3 seconds. So it's just after 3 seconds, you see the model regardless of the size. And what I tested last week, even in my Tesla, I can use UPV while charging the car. Runs perfect. So I was really surprised being able to view a model inside my car. But it's just maybe not the most common use case, but it's possible. So we can build our federated models from various data sources. So here I've just colorized the model based on a data source. So the red one is Smart 3D, the green one was part of an Aviva model, the blue one was an old PDS model. The purple one here in the middle was a drone scan from a drone flyby, and the yellow in the background, that was part of a laser scan. And we can all bring all together in one model, together with drawings, PNIDs, isometric drawings, and I forgot to place all the attributes here. So we can also enrich the model with additional attributes if you need. So one aspect we put a very big effort in the last, let's say, year, and that was laser scans. So what we do is we don't visualize the point cloud, but we generate a high quality 3D textured mesh and reduce the size of the result by about a factor of 100. So, and that allows us, together with our gaming technology and some tweakings, to bring in even huge laser scans. So we talk about 10,000 scans at once in one solid model. So a whole refinery fits into UPV. And if you use browser-based viewing, you have access to this in about 2 to 3 seconds on every client device. Because we use server-based rendering, it doesn't matter which device you are using. Even with a thin client, you can walk in a 10,000 scan model fluently just by opening it up and start looking around. And that's a very good basis of a digital twin, because on top of that, you see it here, I've selected that pump in the scan. We can make our laser scan intelligent. So there is no longer a need to remodel any laser scan to get a valid model. You can just convert laser scan into intelligent objects that behave like objects that come from any source tool like PDS, E3D, Smart 3D, and then add links to other software, add additional data. So without remodeling, it is about 10 times faster and 10 times cheaper than the traditional approach to remodel plants. And you still see everything that was in the plant. So even that hose that hangs here on that pipe, which usually you would not remodel, you can easily use in your model. Okay, one important thing, and that's maybe a little bit detailed information, but it's very important information, is UPV is very open and it's easy to integrate with other software. So we can link to any other software just by adding links into the model. So just by then clicking on an object, you can jump to SAP, your document management system, support files, any web link. You can even add attributes to the calls, so you can call specific websites. That's very easy without a big effort. So it can easily be done. And the other way around is our deep linking, which allows from any external software to open up UPV and select objects or highlight objects by usage of a simple link. So even with an Excel sheet, you can just use the Excel hyperlink command. So without any programming effort, then you can click on the name of a pump and UPV opens up and jumps to that pump. So that's very powerful commands. On top of that, we have a very open and powerful API, so you can really integrate UPV seamlessly into your software. So your software then can drive the 3D view or the PNID of UPV and display the objects you want. And with our SDK, which runs during the model generation, you can enrich your model with things like additional attributes, but even additional graphics. So if you have a look on our sample model on the homepage, you will see that the pipelines have the name on top of the pipelines. So you can easily see which pipe you are looking on without any problem. So that's all possible by the SDK. Okay, so that was an overview on UPV. If you really want to dive into UPV, we can let us know. We can arrange a session where we show what you are interested in. So in the end, that is how it looks like. You can for sure handle it by mouse on touch devices, so all is possible. Okay, I think now we can have a look on the use cases.
Okay, great. Thank you, Sigi. So we'll move on now to the next speaker, Neil from Dow. Neil is the application manager for UPV at Dow. He is based in Alberta, Canada, and has been working with Dow since early 90s in the piping design department. And now he's very involved with the 3D modeling and review tool. So Neil, I will pass it to you to share with us how Dow is using the technology and if you have some of the use cases.
Okay, so these are actually some slides. We've taken a few from what we use typically when we're presenting within Dow. So we just cut these down to keep it from being too long. And as mentioned, I'm part of the 3D visualization team. My name is Neil Armstrong, and I help look after UPV within Dow. Now, this is kind of repeating some of the things that Sigi had already talked about, but it is definitely worth mentioning, I think, highlighting some of the things with UPV. It is quite easy to use. It's been designed to be a fairly user-friendly interface. Attribute data is easily available in there. The search, and this is something I will echo there, the search is very easy to use and quite powerful. And that it allows us to also bring in the drawings, the ISOs, and PNID data available directly in UPV model. These are the areas where we have pretty much now started to use UPV in front-end loading, as well as detail design. We're starting to use it quite a bit. Construction has been using it for a while, and they've started to use it quite heavily as well, and they've kind of took off with it in their direction as well. Operations and maintenance have started using it. Operations, certainly I can speak locally for our local site here. They quite like it and having the ability to view the model quite easily and see what we have in the 3D data for the model, as well as laser scan data. Okay, for some of our use cases, we get quite a lot of use out of the 3D sketching and markups by our designers, both in front end initial setting out of a project, as well as during the main design phase. Quite often we'll have designers here on site or at any of the sites where they will use the sketching to do some preliminary layouts. And then from there, they can share that with the main detail team, who will then pick that up and continue on from that. We're also using it during the main design phase for doing review work in the models, so that the design teams, and especially the design teams, can be global, and we can have design teams in more than one continent. So having the ability for these teams to all be able to review the design as it's going on is again very useful. Animation, we've started to make use of the animation. We've used it for a couple of lift studies where that's been quite helpful, some difficult lift studies. And as I'd mentioned before, the construction team are now starting to use or have been using UPV for their planning, material delivery tracking, and pipeline location. And they've gone to the point where they've really quite embraced it and leveraged things like custom attributes to help with tracking material and so on. Of course, it's also used for construction during field support. Again, it's possible to make a UPV model available on a workstation so that construction teams can easily see the areas they're going to be working on for that particular day or whatever. Maintenance started using UPV for some planning, for when they're doing planning, and also they found, again, with the sketching, it allows them to place scaffolding from the catalog for sketching. Has been very useful for starting to look at how best to utilize the scaffolding for a particular job. Operations, they've been using it quite a bit. They've and actually we've been taking advantage of the deep linking here, where we've been able to generate lists from the UPV models for the equipment, for piping, control valves, so on, and generate Excel lists, so that somebody in operations can go to an Excel list, click on a link, and go straight to that item in the particular UPV model and see it straight away. Again, as mentioned, we're now using it in these areas of design, construction, maintenance, and planning. What we have done, we've actually developed our own system for batch creating UPV models and publishing to a web server. And we go one of two routes. We either go to the web server, or we will publish to a specific project share folder, depending on what the project needs. And we typically will have two types of UPV models. We'll have a more plant specific, and these UPV models, these are the ones that be used more like by operations and perhaps maintenance to somewhat. And these will be the more linked models. And this is where we'll start to leverage more of the linking capabilities with UPV. And these are what you could call longer lifespan models, whereas we plan to use these for as long as we've got the 3D data, we've got that plant. So they could quite often be a model of the whole plant for that particular plant, and we will update it frequently. Maybe it could be anything from once a month or so. We'll keep up these updated so that the operations can have this 3D data readily available. For more project-specific models, these are very much more, if you like, customized 3D UPV models, and they may not be the whole plant. They may be a more focused area where the project is going on. And these are only going to have the lifespan of the project. And these we will update on a much more frequent basis. They can be anything from weekly to daily, depending on what the project wants. And so because of the different needs of a project and what they might want to see in a model, we keep this separate from the models that we would use serving the whole of the plant, if you like. We've also started looking at using UPV models within safety. We've been exploring again for operations to make it easier for new people coming in to become familiar with the plant, know where things are. Again, because of the searching and the deep linking, it's easy for them to go identify where specific items are in the field. And it was even used during lockdowns in COVID, where we actually used the UPV model to create a safety video to help with some safety training. We currently are using the folder browser for accessing the UPV models from the cloud server. And again, this gives us where you can have a web page with links, and you can identify which area you want for that model, click on the link and have the model available. But we are intending to look to move to the browser-based version. And I think that pretty much covers how we're currently using the software within Dow.
Okay, great. Thank you, Neil. Let's move now to the team from Bechtel. We have Gareth Davis and Christian Arostica. So if you can, any one of you, you want to share your screens? Okay, great. We can see it.
Good afternoon, good morning, wherever you guys are. My name is Gareth. I'm going to be introducing the topic here quickly on behalf of Bechtel. And then Christian Araska, who is our UPV expert, he's going to kind of take you guys through how our construction team uses this application. So for those of you who don't know, Bechtel is a EPC company, and we use this application quite prevalently in our construction team. We need to communicate between engineering and our field engineers and construction folks. Next slide, Christian. So we take advantage of UPV's ability to integrate multiple sets of information into one single environment. UPV provides easy access to the engineering data created in multiple sources. In CU here, we have 3D models, P&IDs, structural models from Tecla. And then it also then provides several opportunities for improved validation and collaboration during the engineering phase of the project. These multiple data sets are owned independently by each of these various engineering disciplines. So, you know, like our P&IDs are owned by our process and project engineering folks, while the 3D model is managed by the plant designers. And so with this tool, we have the opportunity to bring these different sets of information together. The 2D is in addition to like 2D information like piping, isometrics, and P&IDs. And then by doing frequently updating the model, we can kind of manage the engineering progress. A good example of how we use this on projects is our process engineering folks will use this for checking our piping routing made during their hydraulic calculations. And then this provides a seamless experience accessing the information all in one place, so they can communicate with the plant designers by making corrections and creating markups. Our CSU team, commission and the startup team, will also use this to visualize the tagged objects within their CSU systems. And you know, this improved collaboration helps to save time and reduce a lot of errors in the design. Now I'll pass it over to Christian, who will take us through how the application is used within our construction by our construction folks.
Right, thank you, Gareth. So mainly for construction, it's been used really heavily, especially for the craft and the superintendent groups, field engineers. It's really useful tools. Right now, we have some workstation on deploy it on different part of the site where the user can even open the model from there, or even from their phone or the tablet or their computer in case they have. We have the offline capability, which is if the user will go to do an inspection where there is no internet, then they can download the model, go there and use the drawings and the model at the same time. I would say one of the biggest features that people really like it right now, it is part of the 2022 and 2023 implementation plan that we're executing now, is this arrow that you have here. It's the most important one. We did all the implementation that was previously presented by the last person, but right now we're taking even more advanced on this one, which is using the API from the Bechtel application tools and using the API from UPV. We are basically exchanging and moving data from the model to the construction application and from the construction application back to the model. So this is really, really important for the advanced work package, because right now we are in the process to implement 3D model scoping, where basically as soon as I click in an object in the model, I can track that information and send that back to the construction database and associate that object back to any IWP testing work package or any kind of volume that I want to include. So I would say that is the most important features that we are exploring on 2023. I created a video here to show, for example, one of the another nice capabilities, where is the interaction between the SSRS report by using the deep linking. So we create the SSRS report with the IWP or testing work package on the SSRS. And as soon as the user click in the IWP, then the system load the model and feed the object for the IWP to display, and we can actually manipulate colors. We can take pictures, move the camera by using the hyperlink. And on this case, I'm also adding what is the simulation for the construction status progress, so we can visually see what is the coloring code per startup system, per construction colors, per any kind of definition. It's really simple to define the color. You can see there, the attribute was there. If I open a second IWP, I don't need to close the model. The model will automatically feed to the second volume by the hyperlink condition definition. If you can see there, I'm visualizing the second IWP. We can define if we only want to see the piece of pipe or anything. We have the hyperlink to open external application. On this case, is the SharePoint where this reside the IWP books. We also have the intelligent drawing for PNIDs and isometric, where the drawings are fully connected between the 3D model and the drawings. So there is an interaction back and forth between the drawing and the 3D model. I would say that is a really useful tool for the craft, because they can get really familiar with the drawings and the 3D models. We didn't have that before with other applications, so it's really, really beneficial. This is the one for constructability sequencing that we're doing. So after the IWP is a scope, or the testing work package is a scope, we are starting to animate the plan. So the superintendent or the field engineer can do the scoping for the IWP, and after that they can actually use this adapter that basically allows them to animate the plan. They can select a specific date, how the plan will look like, or they can do this animation by installation of IWPs. This is only a video, but basically on the real life scenario, is still moving around, so it's not a static model. the user can still continue interacting through the animation process. So that is a really good capabilities from the system. I would say that one of the biggest advances that we have with these tools is that in one of the biggest projects that we had, we were using another 3D visualization tools, and we had to split the model in small sections through that software, but it couldn't even open in some of the computers. And after we did the implementation with UPV, the model size become 25 or 28 gigabytes size. But the model, as soon as the user load the model, it was 5 or 6 minutes to load the model. But after the model was loaded, there were no problem with the performance for the end user. So everyone was able to even visualize the entire plant for the model, which was 28 gigabytes for the performance. The training for users is really low. Basically, it's really minimum. We created some kind of how-to videos for basic interaction. I'll say that probably the software itself, the users right now, they don't even need training. As soon as they open, it's really self-explanatory, and they can use the software really without any special training or any advanced training. And that is all that I have for now. If anyone have any question.
Excellent work. I think you have a question. Let me try to open it. Basically, it's from Manny. Manny is asking, do you also use point cloud data in UPV? And what are your today's use cases?
We are not using that yet, but we are planning to implement that. Right now, we are in the proof of concept to move to the web browsing, which is basically let the users to visualize the model from a web page, and then we are planning to implement that as part of the roadmap, probably for next year.
The way we would use that is if we have a contract that where we have to provide a as-built model back to the owner, we will take that point cloud and compare it against 3D model to find out where the discrepancies are between the actual built design versus the engineered 3D model.
Okay, great.
But as we said, we that's not something we've done yet.
I think Manny had the same question to Neil. So Neil, do you use also point cloud integrated with the data?
Yes. I guess just to be clear here, as Siggy had mentioned, it's not point cloud data. Once we bring it into UPV, it's then mesh data, but we certainly have been using that, and it has worked quite well. And we have, and I mean, we actually have our UPV models where we have point cloud data. Sorry, we have laser scan data. We have 3D data from our own authoring tool, as well as 3D data from other authoring tools as well, all combined in the same UPV model.
Okay, great. Thank you.
Yeah, and I will say the last word. And honestly, between all these 3D software viewer that we try to implement, I would say that mostly all of them do almost the same, right? The hyperlinking, but the biggest difference that we have with this software is the performance, which is working perfectly. That is the biggest difference. There is no special computer needed or anything, so it's the performance is really good.
Okay, great. Thank you. So now for the last section, we'll pass it again to Siggy to share with us what's new with the software, what are the roadmap advancements. So if you can share from your side.
Okay, let me share my screen. Maybe before I continue, just one picture that shows a comparison of a laser scan with a CAD model. So red is the CAD model and blue is the laser scan. And the most obvious difference is that pipe in the top left, where it's missing in the scan. So that's just a live use case I received from one of our clients. So it's actively used that way already. Okay, so a short outlook on our roadmap. So last year, after 9 years of UPV, we started the biggest invest in company history to bring UPV to the next level. And what does it mean? So mainly a new GUI system. We will have a window manager, which allows us to have multi-window. We will have multi-model capabilities and our app controls. So let's dive into those topics. So why a new GUI? Very often we were asked if we can do it in different colors or if we can remove buttons, which is possible in the current version, but we cannot rearrange them. And the simply reason is when we started the project 10 years ago now, we had to do everything by hand. So all the GUI is handmade. It's sometimes inconsistent. So two text fields might behave different because done by two different developers, and it's not flexible. And last year, Unity, the gaming engine we are based on, they published a GUI system, and we decided to move to that GUI system. And the big advantage is it has a common structure, so there are no longer inconsistent input controls, and it's based on a CSS-like approach, like websites are built. So if I now want to change the colors to your company color, it's just one entry in the CSS sheet. Don't be scared. We do it the way that the new GUI firsthand looks exactly like the old software. So you don't have to learn anything new, but we give you the flexibility if you like to rearrange the buttons, change the colors, leave buttons away if you don't need those buttons, and make it even more simple in perspective of the look and feel for the end user. The next big topic, which we were asked very often, is if we can do a multi-window. So let's say 3D side by side with a PNID. And that was simply not possible because when we started it, we designed it like a game. So with one single view. And we are now about to implement a multiple view with a window manager in the background, and that work is so the work here is almost done. That work is almost done. So there are first prototypes running, and it looks quite well. Next thing, we were very often asked, is it possible to have a multi-model approach? So you load in a second UPV model into an already open one. The most common use case for this is if you have huge laser scans and a mixture of those with a CAD model. The calculation of the model, especially for those real huge laser scans, it can take some hours. And now we can just open up the laser scan and additionally only load the updated CAD model, because the laser scan usually doesn't change. So that's in planning. And that's our app controls. That's a cool new feature, and that's a version from last week. So that's already the new GUI system with the new multi-window manager. And what you see here is our standard attributes panel in one window, our files tab in one window, and those two windows, that state live data and HSI zones, those are app controls. And app controls are basically, it can be HTML code, JavaScript code or WebAssembly code. And with that possibility, you can create your own GUI elements or your own workflows inside UPV. So in the future, you will be able to enhance UPV. You have full control to the API of UPV. So you can fully drive UPV from within those app controls. It will run on all platforms. So on the browser-based, on mobile devices, you can either integrate web pages, so where you need some internet connection, but you can also integrate those web pages into the model so they are able to run in an offline mode. So if you have your database with your own safety zones, you can integrate them into the model, download them offline on your iPad, and go offline into the plant on site, and still use those app controls. So that will be a possibility to tailor UPV even more to your needs and give you the flexibility to use the viewer a way you like. And the release date, let's say end of summer this year. We will have the first version ready, and we will for sure provide some samples, and it's no rocket science to integrate your own GUI controls. Okay. That's it. Now, if you have any questions, I do my best to answer them.
Thank you, Sigi. No, I think that's very interesting. I have a question to Bechtel and Dow's team. I saw in one of the presentation, I think Christian was showing how they did the integration with Tecla. So my question is, what is the level of details that you include in the model? For example, in Tecla, what about the steel structure? What is the level? Do you include all the lower level details like the bolts and you load them in the model?
So is that question for me, right?
Yeah.
Okay. So what we do from once the model is being fully detailed from Bechtel, we're doing the detailing for that. Engineering provide us the Tecla IFC files with the key attribute that we are looking for. That include some of the weld information for the steel, all the bolt data, plus the steel members. We include that on UPV, and at the moment that we create the model, we are creating two sessions of the model. One session is the one that includes the full detail with the bolt information, the weld information, and each steel member detail. So for example, when you have a hard stamp or a unique ID for a steel, it's not really one single member, right? It's probably 37 small objects between bolt, weld, and different shape of the steel, right? So in that case, on this fully detailed model, everything will be separated and as it is from the IFC file. And then from what we did with the CAXperts during probably 2 months ago, they provide us the capability to group by the object per the unique ID or per the Tecla ID. So on that model, the second model, everything will be tied together based on the hard stamp or the unique ID. So there are two models that have, for the people that need to see the bolt information or weld information, and then another model that only contain the entire hard stamp as a single object. Okay. But we're including everything in terms of the structural steel. That is starting over probably a year ago. We started to do that, and before, what we had represented in the model was only the steel S3D representation object, but now is the one, the real steel from Tecla detail.
Okay, no, that's clear. Thank you.
And straight from Tecla, I guess straight from Tecla into UPV, or did you go from Tecla into like a S3D or E3D and then into UPV?
No, we don't go through S3D, so it's straight from Tecla. So for all the civil commodities, we are planning to do exactly the same for concrete, for the embed and anchor bolt and steel members, all of them will go straight from the IFC file to UPV.
Okay.
Can I
You have-
ask you
Yeah, go ahead, Julian.
to Neil Armstrong? I heard you said you were using UPV for material tracking. And I also know that the people are using other applications doing the same. And in that case, they are using different color code to define which has been delivered, which has not been delivered, stuff like that. Can you elaborate a little bit in detail how you are using UPV for material tracking?
I probably can't give a great deal of detail. This is an area where the construction team themselves have definitely gotten more involved with it, but they are being able to bring some of that data across from whatever other tools they're using, and by using the UID and a combination of custom attributes, they can then track data in the UPV model, and with the custom attributes, they will colorize based. So like if there's specific dates that something's required, they can use the colorization to highlight what has arrived and what is still outstanding, as well as using the custom attributes for tracking what has already been installed, what's still waiting to be installed.
Awesome. Thank you.
You're welcome.
Do you want to just have one last question with the one that Manny left in the comments?
Yeah,
Okay.
exactly.
Okay, I can read it. This is for Bechtel's team. Manny, he asked, who creates and manages the 4D simulations for your superintendents? Is it the project team that manages the entire process, or do you have a separate BDC/tech team that helps?
Okay, so we are exploring two options. Right now, it's under the project controls team, or probably there are cases where it's the material management person that is kind of analyzing the sequencing for the IWPs. But and then the other implementation that we're doing is we have a application that is kind of using artificial intelligence to recommend the sequencing per the IWPs or the sequencing per the construction volume or per CWP. And using that, we are putting that on the database. So the database provides the format for the system to automatically generate the animation. So we have a kind of a library for the animation, and the user just take the file from there, put that in UPV, and run the animation and define which is the best one for them. So we are trying to be focused on who need the work. They can do that. It's kind of a simple task.
Okay, great. Any other question? I think we have last time for last question, if anyone has a question.
I guess
have a question to the, sorry.
No, go ahead.
Yeah, I have a question to the Bechtel team that integrated Tecla into UPV. Is there a possibility also to look up the fabrication drawings in UPV? Do you integrate to that extent, or it's just the 3D integration?
Yes, it is possible. Same for the piping and same for instrument and other object. As soon as you have a PDF, the system can convert the document in like a semi-intelligent document in case it's PDF. But if the document is a smart sketch format, then the system automatically does the relation between the object and the drawing. So when the model is created and published on the server, then the user open the model, click on the object, and the object will have the relation to any of those automatic drawings. So the answer is yes. Yes.
You could also bring it in from the EMS as well, right?
Yes.
Yeah.
So we are also doing the same relation to create the hyperlink for system document management. In this case, we're using Aconex. So it does the same relation.
Yep.
Everything is automated.
Fantastic. Thanks.
Any last question? Okay, great. I think we're on time. So thank you everyone for attending and thank you for participating in this presentation. Also, I would like you to join me in thanking our presenters for this informative presentation. I think it was very excellent to all of us. Thank you, Siggy, Neil, Gareth, and Christian. And I would like also to thank Lean for stepping in on behalf of Dow to sharing the presentation. Keith also on behalf of Bechtel.
Yeah, we could vote.
So thank you, everyone. Have a good day. Okay, bye-bye.